questions you guys have, want to see, want to do, want to go over? Did I miss anyone else? Anyone else need a review? Colton, Colin, do you both have your reviews? This review that looks like this. This review that looks like this. Colton, did you find it? Colton, did you find it? Miss Harrison, can you press up that? Great. So your first objective was domain, range, interval notation. Do we have any questions on this page or this objective that we want to see, do, go over, have questions about? 1 and 3. One, and it's supposed to be number 2, is asking about domain and range. So domain is your furthest left to furthest right. This has arrows. So that means it's going to keep going down and left and down and right. So keep that in mind. So we're looking from start to end. Where does this start for your domain? That's not where it would start. Look left to right. Where would it start? And someone else said it right there. Negative infinity. Because it's going to keep going off. Where would that end? There. Also infinity. Remember that infinities, negative and positive, you use parentheses. And you could do either notation, your interval notation, or your set notation. So you don't have to write both. It may say use one type of notation or the other, so just know how to write both. Range, lowest to highest. What is your lowest point? Negative infinity. And what is your highest point? 0. And because this is a closed circle, that's going to be a square bracket. If you had open circles, those would be parentheses. Or we can say this is everything underneath or below 0, so that would be y is less than or equal to 0. Questions on 1 before we continue? For 3, it's looking at the intervals, the x intervals, where this is constant. So that means looking left to right, your x values keep moving forward, but your y values stay the same. Where does it start being constant? Where is your y value the same? Left to right. What, and these are really small. This should be -1, -2, -4. Where does it start being constant? Left to right. Sorry. That wasn't the question I was saying. Look at it left to right. At what value does it start? So it's right here. You can improve this one. So we're going to write our x value. Start at -5. It's open, so we're going to use a parenthesis. Where does that stop being constant? -1. There's not an open circle there, so we can assume it to be closed. So square bracket. Is there somewhere else where it's constant? Where would that one start? Positive 1. This point right here. So I'm going to put a U in between these just to mean there's multiple. Positive 1, where does it end? Positive 3. So it's constant. I'm going to highlight it. Here. And here. If this had an arrow that kept going, we would say it's constant from negative infinity to a certain point. It didn't ask this, but just so you remember what this is, what this does. If it said, where is this increasing? So as your x values keep moving forward, where are your y values going up? Looking left to right. Or I could say, what is happening in between here? What are your y values doing as your x's go left to right? It is going up. So here is where you would say it's increasing, but you would write your x values starting at negative 1 and ending at 1. If you were looking left to right and your y values were going down, you would say it's decreasing. But your x values have to be moving also. This would not be decreasing because your x values aren't moving. Okay. What questions do we have on 3? Miss Larson, can you hit new session? Do we have any other questions in this objective? 4. So these are just rewriting it as the other notation. So here we're given set notation and have to write it in interval notation. So you have to think about where would this start and where would this end. If it's x is greater than 1, where would that start? That's where it would end. It would keep going to infinity, but where would it start? 1. So then would the 1 be a bracket, square bracket, or a parenthesis? It doesn't have the equal to, so it'd be the parenthesis. Okay. So for those, think about what number you're starting at, what number you're ending at. Alive. If this had an equal to underneath it, the line underneath it. Like the curly bracket?
Yeah.
For this, I'll show that. You could put this curly bracket, it's not a necessity. Okay. For this other one, it's given in interval notation, we have to write it backwards. So it's from negative infinity to 4. So would that be everything below 4 or everything above 4? Below. So that would have to be less than or equal to. If this is a parenthesis, which one is it? Strictly less than. So it would be everything less than 4, so you can say x or y, doesn't really matter. If you want it to look like this, you would just add in those extra notations. So curly brackets, x, vertical line. You don't need those. You could just leave it like this. There's less than 4. Either works. It's just extra notation. If you get something between two numbers, remember that there are 2. So like if I said between 2 and 4, you would write it as 2 is less than x, which is less than 4. So make sure you have 2 symbols and an x in between them, or a y, whatever you choose. Questions on this objective? Go on to the back. And we'll do 2 from objective 2. Which ones would you like to see? 4 and 2. And one more. Okay. So in this, we're given transformations, bless you, and we have to write the equation based on these transformations. So you have to remember what's given, what type of transformation it is, where it would go, all those things. Okay, so they give you the function x squared. So somewhere in your equation, you're going to have an x and a square. You may have parentheses, you may not. Then it says translated 2 units down. So that's like a shift. Would that be vertical or horizontal? Vertical. Up and down is vertical. Remember that vertical things happen on the outside. And then reflected across the y-axis. So if this is your y-axis and it's going like this, is that horizontal or vertical? Horizontal. So that means that's going to happen on the inside. You have 2 transformations, so both need to be included. So you can start writing. F of x equals, we have something that goes on the outside, but does this go before the parentheses in the front or in the back? In the back. So the only things that go in the front are vertical reflections, vertical stretches, vertical compression. We don't have any of those. So it means our A value is going to be 1, so you can write 1. You don't have to write 1. Then we have a horizontal reflection. How would we show that we have a horizontal reflection? What would we put? So negative before the x. This is an x squared or a quadratic, so you need the square on the outside of the parentheses. And then how would we write 2 units down? Would that be down? Minus 2. Don't add in extra things. If it doesn't say it, don't put it. Questions on that one before we do 4? Okay. 4 has an absolute value. So make sure you have the correct function when you're writing it out. It is stretched horizontally by a scale of 1/2. It tells you what type it is. So that's going to automatically go on the inside. It's reflected across the x-axis. So if this is your x-axis and it's doing this, what type, is it vertical or horizontal? Vertical. So that would be at outside. And translated 12 units left. Is that horizontal or vertical? Horizontal. Okay, so we can start to write our equation. F of x equals, do we have a number that's going to go outside of the absolute value bars? A vertical stretch, compression, or vertical reflection? Do you have any of those? You have horizontal stretch and the reflected. So how would we write the vertical reflection? Just the reflection on the outside. How do we write in a reflection? What tells us it's a reflection? Look at that first example we did. What told us, or what did we write that showed it's a reflection? That was part of the original function, so that was already there. What else here told us that this was going to be the reflection?
And added to that x squared that wasn't there originally.
If you're looking at this and you're comparing it to what we have,
The negative.
the negative. So the negative tells us it's been reflected, so that's going to go on the outside. And we have our absolute value bars. Because it's stretched horizontally, that needs to go first, inside. But because it's also being shifted to the left, we need parentheses inside the absolute value. Otherwise, the 1/2 would affect the shift, so we kind of need it separated. How would we write translated quasi-units left? Would that be plus or would that be minus? It would be minus. It's always, I'm sorry, it's not, you were right. I said backwards. It's always opposite, so plus. And then it would look just like that. So we don't have any vertical shifts, so nothing on the back end. Questions on that? The negative, the reflected. So because it's reflected, we need a negative. Right. Objective 3 is taking the graphs that are given and writing them into equations. So you have to think about your parent function. If you don't remember what that looks like or what those points are, you can always put it in your calculator. So first, is this your x squared function or your absolute values function? Absolute value is your v. This is your x squared. So then, if you're looking for the parent function of x squared in your calculator, you can go in y equals and put in x squared. Go into your table and plot those points. That way you have something to compare it to. So it starts at 0, 0, goes 1, 1, negative 1, 1, 2, 4, negative 2, 4. That would be your parent function. And then what changed between the original and what's given? The parent function went up. So from the original to the new one, what happened? It went down. By how much? It's here. This is your vertex of this. Look at the vertex of this. How far did that move down? Four. What else did it do? Because if it just moved down 4, it would be here. If I'm looking at the points here, the distance is 1, 1. So that's the same. It didn't get wider. It just looks like it because of how it's been moved. How did it get over here if moving it down 4 would move it here? So if I moved it down 4 and then I moved it right 1, it should land directly on top of that. So that should be it. So then we can write our equation. F of x equals our vertical shift down is going to be written on the outside, but at the end, the horizontal shift on the inside. We didn't see there were any reflections or vertical stretches or compressions, so your A value is still just 1. You can write that, you don't have to. How would we write that it went to the right one? X minus 1. And then minus 4 on the outside. We need the square since this was already squared outside of the parentheses. Questions on that? Brian?
Is there still 1 right for the?
You can put it, you don't have to, but yes.
Where did it come from?
It's always there, no matter what. That tells you there wasn't a stretch or compression. Like there's a 1 in front of this one too. Okay. So then this next one is your absolute value function. Again, if you don't know what your absolute value function looks like, your original, you can put that in your calculator. Alpha window will give you that. They start at the same place, 0, 0. They start going to the same points, 1, 1, negative 1, 1. But then it just keeps going up 1, right 1. And up 1, up 1. What changed between these two, the original and the parent, and the one that's given? It did go down by how many? What else? It went this way. It moved to the right again. There's one more thing that happened. Look at the slope between the one that's given and the parent one. Think about that. Okay. Before we left, or right before Wilson said there was a vertical stretch, and that did happen. So if you were to count your slope, it would be a vertical stretch by 2. So then we would use all of these to write our equation, starting with f of x. What would we put first of the 3 transformations? The vertical shift, the horizontal shift, or the vertical shift? Which would come first? Stretch.
So 2 parentheses. Absolute value, yeah. X minus 1. The absolute value. You add the exponent.
Not for this one, because those are 2 different functions.
Okay. And then you put down the minus 3. So when would you be able to add that?
Only if it's a U-shaped function.
Or you can say U-shape.
Correct. If it's a V, you should not have the square at all. And vice versa. Objective 4 is it gives you equations and you have to write out the transformations. So look at the original, look at what's changed. Anything that is different, those are going to be your transformations. And you're going to write out what those things are. So what would the negative on the inside do? No, not in this case. Think about your transformations. Which transformation goes with a negative sign? Say it again. I can't hear you. What were you starting to say? It is a reflection. It's on the inside, so that means it's a horizontal reflection. What would the +5 on the outside do? So that would be a vertical shift of 5. So with your shifts, make sure you're putting vertical or horizontal, what direction and by how much. Questions on that one? On this next one, we see it was just x squared. Now we have a negative and the 8 and the +13. Always make the negative and whatever number is next to it 2 separate things, because those are 2 different transformations. What would this negative on the outside do? And it's on the outside, so it would now be a vertical reflection. Just vertical reflection. The 8 is something else. What would the 8 do? What would the 8 do? Aaron. Not compression, because it's bigger than 1. So stretch. So compression is always going to be a fraction, and that fraction is going to be the numerator smaller than the denominator. What would the +13 do? Horizontal shift. Opposite, yes. And that's it for that. Don't add in things that aren't there. Only put things for the transformations that are. Questions on either of those? And then your last section is graphing your absolute value or quadratic. You can do this in your calculator. You don't have to use the transformations, but you can. It works the same. Regardless, you have to put your vertex. So look at the number on the inside, look at the number on the outside. What would your vertex be? But it's opposite for the 2, so -2, +4. And then before we can graph this, we have to look for any other transformations. So what would this negative do? The negative on the outside, what would that do? Reflect it vertically. So instead of facing up, it's going to face down. This is absolute value because it has the absolute value bars. So it should look like a V, but upside down. Because it was only reflected and not stretched or compressed, the slope is really the same. So down 1, right 1, down 1, left 1. And you need at least 5 points. You can do more than that. Can't do less than that. Have to have 5. Whether you do it based on the vertex and the transformations or do it in your calculator is up to you. But I would highly recommend that you double check it in your calculator. Put it in your y equals. Go to your table and see if your points match. And they should. -2, 4 was our vertex. Then I went to 3, and then 2. -2, 4. Then I went to 3, then I went to 2, and it's going to keep going. Questions on that one before we do this last one? what would the vertex of this one be? -3, -5. Look at the number on the inside and the outside. Flip the number on the inside. That would be your vertex. Did this one have any other transformations happen to it? No, just those two. So it's going to look like the parent function. It's going to be facing up. There wasn't a stretch or compression. So up one, right one, up one, left one, then go out 2 and up 4 on both sides. And if that's based on the parent function. Nope, I didn't even write that. I meant to go to the table. Because we start at the 0, 0, it goes out 1, up 1, and then up 2, or out 2, up 4. So you would do the same thing here. And then you can check yourself. Put that into the calculator. Double check your points. You said -3, -5 was our vertex. Then it should be at -4, -4, and -2, -4. And -5, -1, and -1, -1. So definitely for this objective and objective 3, double check yourself in the calculator. Because you'll be able to see whether you got that right or not. Questions on this? Other questions in general before you guys start your quiz? Same as before, it is collaborative. You can work together. Go ahead and put your phones in a calculator pocket. Clear off your desk except for your calculator and pencil.